So the next term is what they call a biconditional statement. The math shorthand for a biconditional statement is hypothesis, IFF, the conclusion. The IFF means if and only if. You are allowed to write a biconditional statement if the following are true. If both the conditional statement and converse are true. So if you come up with something and you do your analysis and both the conditional statement and the converse are true, you can rewrite it as a single statement called a biconditional statement. Can somebody please tell me what the definition of a right angle is? It's a 90-degree angle. So what I want to do is I want to write that as a conditional statement. Every one of our definitions that we have so far, you can write as a conditional statement. So what I'm going to write for my conditional statement is if an angle measures 90 degrees, comma, then it is a right angle. Some of your homework problems have you take definitions and turn them into conditional statements. Then it says to take those conditional statements, write the inverse, the converse, the contrapositive, and if possible, write a biconditional. So I'm just going to do the biconditional now. If the only way I can write a biconditional is if the converse is true. Actually, is this true? Yes, that's true. So now let's write the converse. Somebody remember what the converse is? Q implies P. So we swap the hypothesis and the conclusion. So the way I'm going to write this is if an angle is a right angle, comma, then it measures 90 degrees. Is that a true statement? So, because this is true, the conditional is true, and the converse is true, I can write a biconditional statement. And that biconditional statement is an angle measures 90 degrees if and only if it is a right angle. Later on this year, we may get some theorems that are written in this form, which means that that theorem goes in both directions. If you have a right angle, you can say it measures 90 degrees. And if you have a 90-degree angle, you can say it is a right angle. Are there any questions on how to determine whether something has a biconditional, and if it does, how to write the biconditional? So if both of these are true, we are guaranteed that this is going to be true. Anytime you have a statement, well, actually you compare two statements, and the two statements are always true at the same time, or they're always false at the same time, we can call those equivalent statements. Okay? These two statements are always true at the same time. These are equivalent statements. Okay? That statement is also an equivalent statement to these statements. So we're going to learn through this year is how I can use equivalent statements to actually start shortcutting ourselves through proofs and stuff like that.